Very good morning, guys. So let's start the session. So today, it's a third part of excretion with All India rank 60 from Life Science. This is Unacademy, India's largest platform. If you want to join and enjoy this platform, it is necessary to install this app in your mobile. Also, this app is available daily update about the lectures. Okay, so the topic of lecture, subject of lecture, and time of a lecture you can see here on this channel. Okay, so if you do not have Telegram, first necessary to download it from App Store and then click on the search and type this URL or link in the search box and then join the Telegram channel. Okay, so you will have the different type of lectures available on this channel, and these are the offers for you. So if you see the subscriptions, these subscriptions are available in 1 month, 3 month, 6 month, 12 month, and 24 month. In a 12, I will recommend you. This is 16,500 fee for a 12 month. But if you use Abhijit in a capital as a code of a subscription, the fees will be only 14,850 rupees. Okay, and you if you are in 11th, complete your 12th. So in this situation, you can take a subscription of 1 month in only 1,499 rupees with the code this capital Abhijit. Okay, so this is how the different facilities are available for you. You can enjoy the unlimited this Unacademy. Okay, so India's largest platform, you can use it unlimitedly. Okay, if you have the subscription. Okay, so let's start with excretion and osmoregulation. So this is a part 3. We already see in a part 2. In part 1, so what are the different type of excretory products and how they are secreted by the animal, and how animal plays important role, or the animal's system plays important role in the excretion. And okay, this renal tubule is your nephron. Okay, so the nephron is a structural and functional unit which is playing a main role in the separation of urine and blood. Still, I take 2 slides to revise it. Okay, so the first slide is this. Here we have the information about PCT and then DCT. These are the three part of a nephron. If you see how they looks like, so for example, this is your nephron. Okay, it looks like this. This is loop of Henle, a smaller diameter tube. The descending part is a very thin, and if you see the ascending part, it is a thick. So there is no absorption of water in the ascending part of a neuron. Okay, sorry, a nephron. So this is how your nephron looks like, and it is connected to the collecting tube. Okay, so this collecting tubule we generally call it a CT. So this part, which is a very please take care that you are in a tubule. Okay, so sorry, I mistakenly pronounced it convoluted. So it's a collecting duct or collecting tubule. Okay, so sometimes it is also called as collecting duct. Collecting duct. Okay, so you can write it collecting duct or collecting tubule. Okay, both are the same thing, and alternatively okay, so in a PCT, that means in the first part here, I am talking about this more folded part. It is composed of cuboidal cell with a numerous microvilli and the mitochondria. So why it required more mitochondria and why there is a microvilli? So this microvilli is because of the reabsorption of water and solute from the filtrate and secrete substances into it. So the secretion and absorption are required more area, and to increase the area we have a microvilli in this type of cell. I that nature is a very smart, so nature had a beautiful facility for the simple thing also. Okay, so in a loop of Henle, it is a hairpin shaped loop of renal tubule, and which is very small in a diameter, which is a thin part of your uh, renal tubule. And if you see the PCT and DCT, it is a thick part having more diameter as compared to the loop of Henle. Okay, so the proximal part is like the proximal convoluted tubule, and the proximal part is followed by the thin segment and thick segment, which is made up of cuboidal, columnar tissues and or the cells, and this thin segment is made up of simple squamous cells. Okay, so this is a thin segment and thick segment of the your loop of Henle. Okay, so the last part is a DCT. We are again going to discuss it in the next slide when we discuss the actual method of urine formation. Okay, so in the mechanism of urine formation very detailed, but here please concentrate and try to understand which part is placed where, and the important characteristic of a parts. Okay, so yellow arch shows half of the part is a thin and the half of the part is made up of thick wall. Okay, so distal convoluted tubule DCT, it's a cuboidal cells. Okay, it is made up of cuboidal cells with that function more in a secretion than the reabsorption. Okay, and here you can see reabsorption and secretion, both things are happen simultaneously, but in a DCT it is a more concentrated or the more specialized for the secretion than the reabsorption. Okay, so the secretion is uh, a major part of your DCT, and absorption and the secretion both are the major part your PCT. Okay, and loop of Henle is involved in two different things. Let's see what is happening in the loop of Henle. So this is a beautiful diagram of your nephron. Okay, so here the blood is coming into the nephron. Okay, so like guys, let's see now what is happening here. So you can say a urine is synthesizing or the made inside of this nephron. So this nephron and this urine flow is moving toward the bladder. Okay, it's a structural part of your pyramid. So guys, are you remember renal pyramids? Renal pyramids. Okay, so this is part of your renal pyramid. Renal pyramids are made up of the nephrons. Okay, so these are the nephron which forms the renal pyramid, and here is the supply of a blood. Okay, so blood is entering into the cup shaped part of your nephron, and this cup shaped part is called as Bowman's capsule. Okay, it is a cup shaped part, cup like structure, and this tubule or the blood is entering into the cup shaped part. So the blood pipe which is entering into the cup shaped part or the Bowman's capsule, we called it apparent arteriole. Apparent. Okay, apparent means which is entering inside of the uh, Bowman's capsule, and here is a efferent part. Efferent capsule. Okay, so the two things keep in mind that so these apparent tubules or the apparent arterioles are the not tubule, it's arteriole, are the larger in a diameter, so they are more in a diameter. Okay, and that is they are wider. Okay, as compared to the efferent are narrow, they are thin and less in a diameter. Okay, so guys, this is very important part. We are going to discuss it in a next slide, because it's a main reason where the urine is separated from the blood. Okay, so we have to keep in mind that this incoming blood pipe is wider, and the moving out of the Bowman's capsule, the blood pipe is thinner. Okay, so let's see this blood pipe inside of the Bowman's capsule form a capillary network, or it is winded inside of the Bowman's capsule. So this winded part or the capillary network is called as. Okay, so what is a glomerulus? Glomerulus is a network of capillary inside of the Bowman capsule. Okay, it is a network of a capillary inside of the Bowman's capsule. So let's see the first folded part or the much folded part of your nephron or the renal tubule. It's a renal tubule, that is nephron. So this part of a nephron is a more folded and close to is a not correct as per the diagram. It is looks like this. In loop of Henle, the diameter is a very narrow or the tube is very narrow, and when it enters into the DCT, it is again. Okay, so tube is a narrow here, but the diagram do not show it, but we know that. Okay, I already told you that the loop of Henle is an arrow, and I draw and last slide here you can see a loop of Henle is a very narrow tube as compared to the DCT and PCT. Okay, but in diagram we do not have this difference, so diagram is not technically correct about loop of Henle, but other things are very beautifully expressed in a diagram, and there is a beauty of a diagram is this red color pipes. Okay, so we will discuss it definitely. So let's see guys, this loop of Henle is again joint or it convert into the larger tube which is again folded more, and we call it a DCT, distal convoluted tubules. Okay, so this is a DCT which is connected toward the collecting duct, okay, or the collecting tubule. So it may be a CD or CT. Okay, so the CT is more commonly used as a shortcut, but CD you do not have. I never see a CD, but the collecting duct is also correct. I already told you there are two name for this collecting duct. One is collecting duct and one is collecting tubule. You can use any one you love. Okay. So this is how the blood filter into the nephron, and the movement of this filtrate is like this from PCT to I'm going to draw here. So here is your blood, okay, which drain material into the Bowman's capsule. Okay, so this Bowman's capsule and the glomerulus. Okay, so Bowman's capsule. One more terminology is there, and the glomerulus. These two things are togetherly called as a Malpighian body. Okay, so these two things is togetherly called as Malpighian body. Okay, so what is Malpighian body? It is a combination, or it is the complete part which include a glomerulus and the Bowman's capsule. Okay, let's see guys, this blood when enter into the Malpighian body, it filters into the nephron or the part of a nephron and enter into the PCT. Then PCT, it will move toward the loop of Henle. Again, I am saying that do not use this short form into the examination. And then collecting tubule. Okay, and then collecting tubule too, it's moving toward the papillae, and then papillae to uh, minor calyx, then major calyx, and finally from the uh, ureter or the moving toward the by the pipe, it is moving toward the bladder. Okay, so this is how the sequence or the series of event happen inside of the our nephron. Okay, so we have a question. Okay, this capillary network is moving toward the veins, and this enter or the ends into the vein. We call it a renal vein. Okay, so it into the renal vein, and we already discussed in a last lecture what is a renal vein. Okay, so the each and every nephron has its own capillary structure which will collect the necessary material again from the urine and move toward the next part of a kidney, and they come together, they form a larger vein. again the capillary comes together, they form again larger capillaries, and then venlets, and with respect to the distance, they form a single vein, a large structure of the pipe of a blood, and it will enter into the your vena cava. Okay, so it will enter into the inferior vena cava, guys. Okay, enter into the inferior, or the attach into with a inferior vena cava, which is moving toward the heart from the lower side of the body, and if it is coming from the if vena cava is coming from the upper side of the body, we call it superior vena cava. Okay. So the structure is moving toward the uh, inferior vena cava. Okay, let's see, guys. I'm going to clear it because I want to explain this red color part now. Okay, so let's start with the red color part in a blue ink. So this red color part is your blood pipe. It's afferent arteriolar. That means it is entering into the Bowman's capsule or Malpighian body, and the capillary, which is a living Malpighian body coming out of the Malpighian body, we call it apparent arteriolar. Okay, so the apparent and efferent arteriolar, and this is apparent. Okay, so guys, let's see what happened. Because of the larger diameter and the smaller diameter here, and the larger diameter here, what happened? The pressure increases inside of the Malpighian body or the Bowman's capsule or the glomerulus. Okay, so the three things are the same. Because of high pressure, the material from blood is going to enter into the, we know here are the few type of cells, we call it podocytes. They have food processes. We already discussed how these food processes and the slits involved in the filtration of the blood. Okay, and this urine is now moving toward the collecting duct. Okay, and this pipe is again having a contact with the renal tubule and moving simultaneously or parallelly with the renal tubule, having maximum contact. So it coil on a renal tubule so that it will have a maximum contact with the renal tubule. So this blood pipe or the capillary network of a capillary, we call it a vasa recta. Okay, so what is this? This is a vasa recta. This name is not included in your figure, but you can write it here like this. It's a vasa recta. Vasa recta means the network of the capillary which is moving with the renal tubule. Okay, so let's see what happened in the renal tubule. So the urine formation starts from the first part. We call it a Malpighian body. That is the Bowman's capsule and the glomerulus. They are here in the cup-shaped structure. Okay, so this cup-shaped structure is called as Bowman's capsule, and the capillary network inside of the cup shape or the Bowman's capsule is called as glomerulus. So in this glomerulus, what happened? The diameter is a larger here and the diameter is very narrow here. So because of that, it increases pressure, and because of the high pressure, the blood enter into the renal tubule, or the, you can say, in a nephron, and this process is called as ultrafiltration. Okay, so the why it is ultrafiltration? Because it is happen on the high pressure. Okay, so the pressure is more here. So due to the pressure, we call it ultrafiltration. Okay, so the any filtration, you can say ultrafiltration if there is a more pressure for the filtration. Okay, so what is a glomerulus? It's a network of a blood pipe, or you can say a capillaries inside of Bowman's capsule. Okay, inside of Bowman's capsule. So the difference between afferent and efferent. Okay, so the incoming is afferent, and which is moving out is called as efferent. So the difference between afferent and diameter difference between afferent and efferent, you can see here is a larger inner diameter and smaller inner diameter. So it apply pressure which is normally equal to the 55 mm of Hg. Okay, but due to the opposite osmotic pressure and the a capsular pressure. Okay, so here is again opposite osmotic pressure because there is a liquid inside, so it is also going to oppose the liquid which is coming inside, and there is osmotic pressure also because of the uh, balanced, which is sodium, potassium or the other salt which hamper the balance, and it again apply the opposite pressure toward the capillaries and not allowing the material enter into the this renal tubule. But if you see the total pressure which is opposing the material is a 30 which is osmotic pressure and 15 mm of Hg which is a capsular pressure. So these pressures are the opposite in the pressure of this 55 mm of Hg. So just a summing or the make addition of this, so we will have the 45 mm of Hg which is opposite in the direction of 55 mm of Hg. So I'm going to minus this pressure from the 55 mm of Hg, and we have a 10 mm of Hg which is a net pressure for the filtration, and this pressure is called as glomerular filtration pressure or the glomerular filtration rate. Rate means the quantity of a liquid which is filtered in a unit time, so we call it a rate. Okay, so this pressure is a net pressure required for the filtration of urine. Okay, so it's a net value. The total value is 55 mmHg, but there is again a reverse. Okay, so let's see guys what is happening here. So this is your Bowman's capsule. Okay, I am not going to draw it completely. And here is a pressure of blood. Why? Because of the diameter which is coming inside is a larger in a diameter, and which is moving is a smaller in a diameter. So there is a more pressure inside of the this structure, and this pressure is a 55 mm of Hg. So 55 mm of Hg is in this direction, but there are two pressure working simultaneously on this 55. One is a 33 in the opposite direction of 30 in the opposite direction of 55, and one is a 15 in the opposite direction of 55. So we just minus it, and there is a net effective pressure. We call it net effective pressure, that is 10 mm of Hg. Okay, so the net pressure is 10 mm of Hg. At this pressure, or because of this pressure, blood is filtered or the blood enter into the nephron for the filtration. But if you see the surface of a nephron by which a blood is filtered, it is not allowing any cell to enter into the nephron. Otherwise RBC will enter into the nephron, they will come out of the body from your urine. Okay, and it is not happen, we know that. That's why we can say the cells of blood will not allow to enter into the nephron. Okay, so this is one thing you have to keep in mind. Only liquid part, water and the salt and minerals, and the other thing which is a dissolved uh, or non-dissolved form, in the dissolved or non-dissolved form in the blood, which is going to enter inside of the nephron because of this pressure. Okay, let's see what happened after this glomerule. Okay, so glomerule complete its function, and now your uh, urine is entering into the PCT. Okay, so the entering into the proximal convoluted tubule. So here selective reabsorption is a happen. Okay, so what is meant by selective reabsorption, guys? So this PCT absorb material. Why it is going to absorb the material? Let's see. Here in the PCT, uh, for example, glucose is there, it is necessary, so it is absorbed again into the blood. Amino acid is necessary, again absorbed. So any material which is necessary, it is absorbed by the PCT. Okay, so there is different things which are very necessary for the our body, or we can say a food part of our body is absorbed, like sodium, chlorine, and the potassium is also absorbed. Okay, so the sodium is also absorbed, potassium is also absorbed, so urea is also absorbed here. Okay, so you can now you have the question, why urea, sir? Okay, so because of the pressure difference or the osmotic pressure, so a small amount of urea is also filtered into the blood. So what is meant by absorb? It is now moving into the blood. Okay, it is moving into the blood. Okay, so the water, which is a very a main component or the important component, which is absorbed here. So this arrow is moving toward the where I write, but actually it is correct when you see it's absorbed, and uh, this material is entered into the blood. Okay, so it is again absorbed into the blood. So 90% of a part is absorbed in your PCT. Okay, and this absorption into the blood, what happened? First blood secrete most of the part here into the renal tubule, and now we are going to again absorb it. So the second process of absorption, we call it a reabsorption into the blood. Okay, so it is a selective reabsorption. That means there are few channels or transporter protein. Okay, and they are specific. We know that they are specific, always specific for the particular molecule, and that's why we call it a selective. Okay, so this is a selective, that means a selective. Is there any question, guys? Getting? So the columnar cells having microvilli increase the area uh, for the absorption. Okay, so it's a area for the absorption is there. Okay, not a P. So it's a area for the absorption or area of absorption. Okay, so its P is like it is O. Mistakenly I type P there. Okay, so it's a O. So increase the area of absorption. A diffusion is active or passive depending upon the concentration of the molecule. If it is opposite to the concentration, it requires energy or ATP, which convert into the ADP. So it's active, and if it is toward the concentration gradient, so it's a passive, and sometime there is a facilitated diffusion, and we know that facilitated diffusion is also a passive process. Okay, so let's see the important substance which are necessary for the our body, or you can say the food part, like glucose, amino acid, okay, sodium, then K plus, water. These are the food parts, and they are absorbed against the concentration gradient into the blood. Okay, so they are absorbed against the concentration gradient into the blood, and it required the against concentration gradient means opposite to the concentration gradient, and so it required energy, and that's why I use that word active transport. Okay, we know that active means it energy required energy in the form of ATP. Okay, so the if you see the transport is using your energy or the ATP from your body, at that time you can say it's an active transport. Okay, so in this part what happened, the S2 is absorbed. Okay, S2 is absorbed, and the food part, or you can say a necessary part, which is also absorbed again into the blood. Okay, so this process is called as reabsorption. Guys, let's see, we already discussed the first process, we called it ultrafiltration. Now the second process is a reabsorption, and here is a third part of the your urine formation, we called it augmentation or the tubular secretion. Okay, so this is a secretion part. Okay, why it is necessary? Let's see. Let me draw one nephron here beautifully. The second part is more important, so I'm going to draw a second part beautifully, and the other thing you can understand. So here is not necessary to draw. So it's a loop of Henle, very thin part, and now This is part of our interest here. Okay. The diagrams in biology, if you see, they are very easy to draw. Okay, if you draw the diagram beautifully in your examination, so you will have the more marks. Uh, Otherwise, the bad representation will definitely decrease your marks if there is a good explanation. Okay, so the your good explanation always required a good beautiful diagram. Let's see guys, this is a DCT and we are here now in the DCT, and this is your CT, or the collecting tubule or the collecting duct. This is a collecting duct and this is a DCT. So we are here. Just think about this area. Okay, do not think about the area which is left side of the part. Okay, so guys, here what happened, in this DCT, the secretion of waste material into the lumen is started. Okay, so the what is meant by secretion of waste material? So we know the blood pipe which is coming out of the glomerulus or the Bowman's capsule or the Malpighian body, you can simply say, is moving like this with your renal tubule, so that it will have a maximum contact with your uh, and moving toward the again renal vein. Okay, so it is moving toward the renal vein. So what happened here in this structure, the material which is inside of the urine or the capillary or the you can say lumen is now again moving out, at the same time the material which is inside of the blood is again going to enter into the lumen here. So which is a waste, still it is inside of the blood. Okay, so the waste material in blood secreted into the lumen. Okay, so the DCT absorb waste like creatinine and ions like K plus and H plus from the capillaries and secrete into the lumen. Okay, so this wall of a DCT, let's see the wall of DCT. For example, this is the wall of DCT. Okay, this is a wall of DCT, and here is your capillary in the red color. So this is a capillary very close to the your DCT. Okay, the blood is moving from here. Here is your blood, and this part is your DCT. Okay, so here is a lumen of DCT. The second side of DCT is here. Okay, so this is how the DCT looks like. So we have a nucleus inside of the cell. These cells are do not having any microvilli like structures, we already discussed. So in this DCT, what happens? So any waste inside of the blood will absorb by this cell and again through inside of the DCT. So we call it a secretion. Actually, secretion word is not correct. Okay, because this cell of DCT are not your gland. Okay, so these are the not glands. So the secretion is not correct. But the very first time it is used by scientists, and still we use it. So that there is another word you can use it, augmentation. Okay, so we have question now. Okay, okay, the very good question we have, guys. So it is a waste. Let's see, guys. This lumen of DCT is a part of your excretory system. Okay, so the any material inside of a DCT is a moving. out of the body. Okay, that's why DCT absorb it. The question is that, guys, the question is that if it is a waste material inside of the inside of the blood, why DCT absorb it? Because the job of a DCT is absorb this material or take this material from a blood and throw it out of your body. So that's why it is necessary to absorb this material from a waste. Okay, so this material is now I want to throw out of the body, and that time the material inside of a blood is absorbed by your DCT, and it is thrown out of the body. So this is called as a secretion. Okay, so in this area of DCT, what happens? The concentration of urine is a change. Actually, the concentration of urine, if you see in the PCT and the loop of Henle, it's alkaline. Okay, but in the DCT, it's acidic. So it is very necessary to work by the DCT to change the concentration of the acid-base balance and maintain the urine and its pH. Okay, so DCT is involved in the maintain the pH of the urine and also convert alkaline urine into the acidic urine. Okay, so this part is also important to maintain the acid base balance of your blood. Okay, so this part is also that means it is also necessary to maintain the acid base balance in your body. Okay, so there are a lot of reactions and a lot of things we can discuss, but now for a while let's concentrate on few things. So what is happening inside of the DCT, what is going in and what is going out? It doesn't mean that, guys, DCT absorb and absorb from blood and drop material or the throw material into the lumen. It doesn't mean that there is a no way of transport from DCT to blood. Okay, so it is also happening here. When a DCT is starting absorb sodium. Okay, so now sodium is coming out of the DCT and enter into the blood. Okay, enter into the blood. That time the sodium transporter on the wall of a DCT, it requires a K plus to move inside. We know the sodium potassium pump work together, and that time K is also enter into the another part of a DCT. K and H plus is again enter into the DCT. Okay, so the part which is not required by blood is throwing inside of the DCT, and that's why it shows acidic pH in a urine. Okay, so because of this H plus and the K plus which is entering into the urine in a more amount, it will result into the acidity of your urine. Okay, so let's see the second thing. There is also few things which are coming out of the DCT. So sodium is also coming out of the DCT. Chlorine is also coming out of the DCT. Potassium, calcium, magnesium. These things, these ions are also coming out of the DCT and enter into the blood again, because body do not want to throw this out of the uh, blood. Okay, the second thing, a very important, the collecting duct also involved in the absorption of sodium plus and through into the blood, absorption of a chlorine and also through into the blood, and urea is also absorbed in a few amount or the very less amount by your CT and through into the blood. Okay, so this is how the secretion or the augmentation happens inside of the body, and it result into the high concentration of urine, and again you can say the pH of urine is a change from alkaline to acidic. Otherwise the alkaline urine is a throw out of your body. Okay, so there is again the enzymes. Let's see how the enzymes in a renal tubule are placed. So there are few enzymes which is placed in your renal tubule here. Okay, so this is your carbonic anhydrase enzyme which can convert HCO3 and plus H which is coming inside, okay, into the H2CO3 and again CO2 plus H2O. Okay, so this process is opposite. So it is also necessary to maintain the acid base balance. Okay, so it is not like that, guys. It is completely depending upon the transport. There are lots of thing, lots of enzyme, a lot of ATP, lot of passive, lot of active transports are involved to maintain the different type of the solute minerals and the water concentration. Okay, so if you see the large part of your blood volume is enter into the this Bowman's capsule, but the 90% water is absorbed here only, and the 10% water is absorbed from your loop of Henle to the CT. Only a PCT involved in the 90% water reabsorption. You can see how this process is happen. Okay, so what happen, guys? Let's say the very a good example or the beauty of nature, because of a low concentration of urine into the blood. So blood only have 0.1 to 0.3% of urine. So it is very difficult or close to the impossible to absorb this material from your 100% blood. Okay, so in blood this material is present in a very minute quantity, and it is very difficult to absorb. So what happens? The most of the part of the blood is enter into the nephron or the renal tubule. Okay, so the most of the part is enter, and now what is required is again absorbed in a blood, and what is not required is moving as a urine out of the body. Okay, so it doesn't matter, urine do not contain any molecule which is our food, or which is a part of our the necessary, or the we call it vital. Okay, so the vital food or vital minerals and the different part is also moving out of the body with the urine, but that time it is not required. If required, there is again arrangement the inside of the renal tubule or the in the wall of a renal tubule to absorb it again into the blood, and blood will not going to secrete this type of material, which is very necessary for us inside of the urine. But we know if there is any vitamin which is water soluble and you take it more, it should move out of the body with your urine. Okay, so the any material which is more in a body and it is what we call it the soluble in water, so it can enter or it can leave your body with the urine. Okay, so that's why the material which is more, it is also secreted by urine. The material which is less also absorbed by blood from the urine. So this process is a very a balanced process. Okay, so the material which is required are not going to leave the part of a nephron. It will definitely absorb by taking a different type of action and again enter into the blood. Okay, so this is how the process happen. Okay, so the acid base balance required two things. Okay, sodium and H2O. Okay, so the absorption and sodium, these two component plays main role in a blood pressure maintenance. Okay, so these are involved in the blood pressure, and this mechanism is necessary for acid base balance of the blood. Okay, which mechanism? SCO3 and H plus. Okay, so this bicarbonate and the hydrogen atom are the very necessary for your acid base balance of a blood, and this sodium and H plus concentration is required to maintain the blood pressure. Otherwise the blood pressure of our body will definitely harm. And let's see how. Okay, so now we are going to enter how the urine is synthesized inside of the body. So guys, let's take a screenshot of this slide, because I do not have the diagram like this in my slides anyway. Okay, so this is a complete overview of your urine formation. So the material which is very necessary is absorbed. Please take a screenshot. It is more beautiful than what we draw. Okay, so the urea, uric acid, creatinine and some drugs, if you take drugs, they are also move out of the body from PCT and sometimes DCT also, depending upon the drug. Okay, So these are going inside of the lumen. So it is absorbed in blood. It is moving into the urine. Okay, water is moving out in the a part of your descending part of your loop of Henle, and here is a ascending part which shows a thick wall, and because of that water is not came out of this part. Okay, so this is not permeable to water like this part which is very permeable to water. So the water loop of Henle, and if you see the pressure is increased into the loop of Henle because the diameter is very small, and that's why water can absorb efficiently from this area. Okay, now let's see guys, in DCT we have DCT here. So in DCT, the material is absorbed into the blood, that is sodium, chlorine, HCO3 and H2O. So HCO3 is a conditional depending upon the things, if it is more or less. Okay, but if you see, I already told you the urine concentration or the pH of urine is alkaline here, but after DCT it is acid, and the reason is absorption of HCO3 and the secretion of H plus inside of the urine. Okay, so here is also secretion of ammonia inside of the DCT, and in collecting duct absorption of urea and H2 is also happen. Okay, so this is the complete process of formation of urea or the filtration of the blood for the excretion. Okay, so guys, let's see. You can write it if you want. Please write it down. It is very necessary. If you understand this part of your uh, excretion, you will understand everything inside of the excretion. So please write it down. So is there a question you can ask me? Okay, so let's move. Okay, those who are not completed with the diagram, please take a screenshot. Composition of urine. So the urine, when the completion of this process of formation of urine, if you see the urine here, so this arrow means does not it is coming out of the tubule. Urine is now here inside of the this tube. It is going to the minor calyx and major calyx, and finally into the bladder. Okay, so the composition of urine is like it is pale yellow in a color, and transparent, okay, not 100%, but it is a transparent. And the color is because of a urochrome which is present inside of the urine. So the color is because of urochrome. Please write it down, this word is very important. Okay, and if you see in a defecation, that is a digestive system, the color is because of the two things. One is bilirubin and second is biliverdin. Okay, so the concentration of urine in a blood is 0.01% to the 0.03% of the blood, and the concentration is getting more, or the because of any reason the concentration is more than the 0.05%, we call it a uremia. Okay, what is it? It is a uremia. So uremia is a disease in which the concentration of urine is increased inside of the blood. Okay, the concentration of urine in a blood is about 300 milli osmotic pressure. It's a osmotic pressure, osmolarity per liter. Okay, so it shows the something about osmotic pressure. It's a osmolarity of the blood in the sense of urine. Okay, the synthesis of urine is about 125 ml per minute. So it per day we filter 180 liter blood. Okay, so our kidney filter 180 liter blood. We have 4 to 5 liter blood, so the total filtration is 180 liter per day. So you can calculate how many time blood will move from your kidney, okay, in one day. So in the result of this 180 liter to 200 liter per day is 1.9 liter, or the 2 liter of blood, you can say near about a 2 liter of, sorry, not a blood, 2 liter of urine per day is a formed inside of the body. Okay, so near about 2 liter, it's a 1.8 or 1.9 liter, or near about 2 liter, you can say the blood is formed in a normal human per day. Sorry, not a blood, again I said the urine is a form in a normal human. So the control of urine formation. Okay, so we are going to see the control of urine formation. So for example, you take a more water. Okay, let's say now we have a space here. You take a more water and uh, less excretion exertion. Okay, so the what happen, the less exertion or the less work. Okay, so the less exertion and more water will result in a more body fluid. Okay, so the one condition is this, and the second condition, if you take less water and more exertion is there, so because of more exertion and the less water, your body fluid get decreased, less body fluid. Okay, so what is body fluid? Body fluid means it's your blood. Okay, so it results in a low blood pressure because there is a low blood volume. Body fluid means blood, and here more blood pressure because of more blood volume. So in these two conditions, the rate of urine formation is changed. Okay, so it result in a change in a urine concentration. Okay, so the how urine is concentrated and how urine is diluted. Okay, let's see. Let's start from the second condition first. So ADH is a part of your second condition. Okay, when there is a less water in your body, that means a less blood volume. Okay, and because of the low water in your blood, there is a high concentration of solute, that means sodium mostly is necessary to understand the concentration of a blood. I mean, understand means not for us but for the hypothalamus. So hypothalamus can measure this type of a thing, the water, blood volume, and the concentration of sodium. And then hypothalamus get stimulated and it release ADH in the pituitary gland, the posterior part of the pituitary gland. Okay, so the hypothalamus release ADH from the its a neuron connection with the posterior pituitary, and it result into the secretion of ADH from the posterior pituitary into the blood. Okay, now your ADH is enter into the blood. So what is ADH? It's a antidiuretic hormone, or we call it a vasopressin. Okay, so the second name is a vasopressin for ADH. Okay, so ADH come and act on the DCT and CT. Okay, so the DCT and CT is like, this is a loop of Henle. I'm not going to draw the complete diagram here. So this is a loop of Henle. Here is your it's a collecting duct having different type of connection of neurons. Okay, so your ADH come and act here. Okay, so when ADH come, it result in the more absorption of sodium ion into the blood. Okay, now the sodium ion is more into the blood, and that's why it follows the osmotic pressure is also more here, and it follows automatic draw the water from the blood, sorry, water from the urine. Okay, so here water from the urine is also draw or the absorb from the DCT. Okay, so guys, this ADH having a two effect. One is a direct toward the DCT and CT. Okay, DCT and CT collecting tubules. So because now guys, we have a question why it act on DCT and CT, because here are the cells on the DCT. These cells having a receptor for the this ADH, it will come and sit on the receptor of the cell. Okay, so these cells are looks like this, and here is your membrane of DCT. Okay, so this is inside of the DCT, and this is a cell which is on the membrane of a DCT. Okay, so when this ADH comes, it will bind to the receptor and again start the production of a protein. This production of a protein is nothing but the pumps which are sodium potassium pumps. Okay, so you ask, so I explain it. Okay, so it's a very deep, it's about the gene expression which is started or initiated because of this ADH. Okay, so here is absorption of sodium into the blood, and potassium is through into the, we call what we call it a lumen. Okay, so into the lumen, potassium is entered into the lumen and sodium is moving out of the cell. But now it is only about this cell. Now just think, our urine is here, so there is no effect on urine. So what happened, after some time the sodium concentration in this cell will going to decrease, and that's why the second effect of ADH on this cell is expression of a second pump. Okay, it is not active but it is placed here, and due to the concentration gradient the sodium is now entering into the, okay, so let's rough it so we will have the more space. So now sodium is enter into the this cell, and from this cell it is going to the blood. Okay, and it is because of a single ADH hormone, and that time what happened, the concentration of solute in a blood is a more, so it absorb H2O from DCT. Okay, so the when sodium absorbed by a blood, so there is also a follower of yes, sodium, and that is a water. Water also come out of the pipe from where the sodium you absorb. Okay, what happened? The concentration of sodium is more in a blood now. Okay, so the high sodium and a low sodium. Okay, so what happened? Because of this low sodium and high sodium, there is a gap, or the gap of concentration, we call it DPD. Okay, diffusion pressure deficit, and it applies the pressure, and 1 to sodium again enter into the this lumen. Okay, but there is no any a pump which is going to pump this sodium from this concentration or this side of a blood, so it's a blood, to the lumen, and that's why to reduce this pressure, osmosis started, and blood, sorry, the water enter into the blood. Okay, so now S2 is entering into the blood from urine. Okay, so let's see what is our goal. Actually, what happened? The blood volume is get decreased because of the water is get decreased. And what is happening here? Here S2 is again entering into the blood. So now we are moving toward the makeup of a blood volume, and this process is completely depending upon the ADH. But there is a second part of ADH is also. Okay, let's see what is the second part. What is the second effect of ADH? When ADH secretes in a blood, it simultaneously moves toward the kidney, that is a DCT, and the CT we already explained. Here is absorption of sodium followed by the absorption of H2O. Okay, and more water in H2O. Okay, so at the same time it moves toward the body part and act as a vasoconstrictor. Okay, so the blood vessels which are looking like this, when ADH come, they got a contact with ADH, they will looks like this. Okay, so the blood vessel is now narrower, and because of that it results in a increase in a blood pressure. So blood pressure is increased, and what was our goal? So due to the low water, the blood pressure is also low, and that's why we are trying, or our body is trying to increase the blood pressure, and here it achieve the more blood pressure due to the vasoconstriction. Okay, so when ADH comes, it also increase the aquaporin in this part. So aquaporins are the transporter. Aquaporin 2 is a transporter which is placed in the DCT and act like this. It absorbs water from urine to the blood. Okay, so this is how your DCT plays a role in the maintenance of water and salt in our body. Okay, so let's see guys, RAS stimulation. So this is a second pathway for the maintenance of your concentration of the blood. Okay, here is a different type of a nephron, we call it a JJ apparatus or JJ nephron, that is a juxta glomerulus nephron. Okay, so in this nephron a slightly change is there. If you see the glomerulus structure here and the DCT, they are very close to each other, and in this close contact there is a blackish color tissue I draw here. These tissues are the juxtaglomerular cell. Okay, so densa macula is here, macula densa. Okay, in the DCT, let's see what happened. So here is also a contact of your nervous system, the sympathetic nervous system, which is making a contact with this juxtaglomerulus apparatus. Okay, so here is a different type of controls involved in the RAS system. So when blood volume get decreased, that means water get decreased. So it results in decrease in glomerular filtration rate. So GFR, or the filtration pressure is also get decreased. Okay, so this low pressure stimulate your JG cell, juxtaglomerulus cell. Okay, which secrete renin. Okay, this cell secretes renin, this renin enter into the bloodstream. Okay, now the question is that if they secrete renin, the renin has two chances, one into the lumen and second into the blood. But it enter into the blood, it is impermeable. The wall of your DCT is impermeable for your renin, so it will enter into the blood and move through the blood. So it is an enzyme. Okay, this enzyme act on the another a protein which is secreted by the liver. Okay, so this enzyme is moving toward the another protein which is secreted by the liver. We called it angiotensinogen. Angiotensinogen. Okay, so this angiotensinogen is converted into the angiotensin 1. Angiotensin 1. Okay, do not use short form. I am using here the short form because of the time. Okay, please do not write this type of short forms in your examination, guys. Okay, so now this angiotensin 1 is active as compared to the angiotensin. Okay, and this angiotensin is a large protein. It is a large protein cut by a renin. Renin is enzyme now, and the large protein is cut into the 10 amino acid. So you can say decapeptide to the angiotensin 1, and this 10 amino acid again cut or they move to the lung. Okay, let's see very detailed into the lung. When they enter into the lung, okay, this is the lung. When they enter into the lung, they come out of the lung like angiotensin 2. Okay, it is a peptide made up of 8 amino acid, octapeptide. So in the lung there is one enzyme, ACE, angiotensin converting enzyme. Okay, you I know that you heard this name many times because this enzyme is very famous, and most of the time people find the drug on this enzyme because there are thousands of reasons to block or to activate these enzymes. Okay, so just see in not in a very detail, but overview I can give you. Okay, so this AC angiotensin converting enzyme convert this angiotensin 1 into the angiotensin 2. It is now more active. Okay, it is now more active. It is a potent vasoconstriction. Okay, so it is potent vasoconstrictors. So that means it is going to contract or reduce the diameter of a blood vessel. So your blood vessels looks like this, and because of the angiotensin 2 it will convert and looks like this. Okay, so the contraction, so it result in a high blood pressure. Okay, so from where we start, blood volume is low, that means it will reduce the blood pressure. So we again started from the blood pressure and now we achieve the blood pressure, but the blood volume is still slows down, or the it's low. So the next part at the angiotensin 2 again move toward the adrenal cortex. Okay, so it is now coming toward the kidney. Here is adrenal gland, a triangular gland placed on the kidney. We call it suprarenal because it is placed on the kidney. If you see, this gland is looks like this, triangular. Okay, and there are two part of this gland. One is a cortex and one is a medulla. Okay, so from the cortex, uh, angiotensin 2 activate the cortex, and cortex secretes a one hormone. Can you guess, guys? It's aldosterone. Aldosterone. Okay. So this aldosterone hormone again act on your DCT and PCT and absorb the sodium and water from the DCT and PCT. Let's see guys what happened. The first thing, your extramedullary cell secretes renin, and then renin moves toward the angiotensinogen, which convert into the angiotensin 1, and angiotensin 1 is converted into the angiotensin 2, which is a very good uh, vasoconstrictor, and the this function is played by your lung. A lung has ACE, angiotensin converting enzyme, in the epithelial or the endothelial cell of your lung. Okay, so it is a brush border enzyme. It is always placed on the a cell of capillaries, or the cell which is on the border of blood. Okay, so they are placed, they are not secreted inside of the blood. Okay, so they are only held by the pipes, and they convert it into angiotensin 2. This angiotensin 2 stimulate the adrenal cortex, which secretes aldosterone, and then aldosterone moves toward the DCT and PCT. Now let's see, it moves toward the DCT and activate the sodium potassium pump, and it absorb the more sodium in blood. And we know that because of more sodium in the blood, there is absorption of water. So who follow the sodium? Water. So the more water inside of the blood, and now the volume of the blood is increasing. Blood volume is now going to increase, and this was our aim. Let's see, we started from the low blood volume, and we end with a high blood volume, and we started from the low blood pressure. Let's see here, we end up with the high blood pressure till the volume is maintained by the uh, blood. Okay, so what happened when the volume is maintained? The again act on the JG cell, and this JG cell again uh, stop or the decrease renin production. So when renin is low in a blood, so it is not going to convert now the more angiotensin into the angiotensin 1. So the less angiotensin 1 again result in a less angiotensin 2, and again result in the keys in a production of aldosterone, and it will comes to the normal. Okay, so this nervous system is because here we in the sympathetic nervous system, when there is a low supply to the sympathetic nervous system because of a low blood pressure. Okay, so we know the blood pressure is a low, that's why the low blood supply to the sympathetic nervous system, and then sympathetic nervous system gets stimulated. It's a part of autonomic nervous system, ANS. Okay, sympathetic and parasympathetic. Okay, so the sympathetic nervous system got a very slow blood supply or low blood supply. That time it will activate direct the JG cell. It does not require any permission from the hypothalamus or other type of systems of a body. It will directly activate the renin production in a JG cell, and again the more renin, that means more conversion of angiotensin into the angiotensin 1, sorry, angiotensinogen into the angiotensin 1, and 1 to 2 by ACE, and 2 to aldosterone, and aldosterone to more absorption of sodium inside of the blood, and the more retention of water. Okay, and so this is a positive and negative control of your blood, or the volume of a blood having with your urine concentration or the formation of urine. Okay, so guys, are you understanding? Are you getting? Is it easy? Okay, it is very easy. Please take a screenshot of this slide. So these are the causes for the stimulation of your RAS system. Okay, so it is called as RAS system. What is a RAS? It's a renin, angiotensin, aldosterone system. Okay, so we call it a RAS. Okay, so low GFR means a glomerular filtration rate, low blood pressure, a low blood fluid. Actually, low blood fluid results in a low blood pressure, and because of low fluid, it means there is a high concentration of solute inside of the blood, so it shows a high osmotic pressure. And which concentration? The mostly sodium and potassium are the sensitive or the considered as a stimulator of the RAS system. Okay, so we have two type of system. One is ADH. First one is ADH, and second one is RAS. They work at the low concentration of body fluid to increase the maintain the body fluid. Okay, now what happen in a second condition if you take, okay, so this is a beautiful diagram which represent again what we draw. Okay, so let's, because of dehydration we have a low blood pressure or the low blood volume. So now the volume is a decrease, blood pressure is a decrease, and in the JJ apparatus of a kidney, it secretes renin. Renin converts angiotensin, which is came from the liver. Okay, convert into the angiotensin 1. So renin here act as an enzyme. Okay, angiotensin 1 when enter into the lung and came out of the lung, when it came out of the lung, it is angiotensin 2. Okay, because of the angiotensin converting enzyme which is placed in the lung or the capillaries or the border of the cell, which is a brush border enzyme, we sometimes call it a brush border enzymes. This type of enzymes are present into the intestine. Okay, so in intestine they convert sucrose into the monosaccharide, or most of the time the polysaccharide or pieces of polysaccharide into the mono and disaccharides. Okay, so these enzymes are also present in the digestive system. This type of, not ACE, but the brush border enzymes, that means which are attached or they are hanging on the wall of the pipe. Okay, so this angiotensin 2 is a potent vasoconstrictor, so it causes a contraction of the blood pipes and it will result in a high blood pressure. Okay, so the blood pressure is now again regaining its position or the its number. At the same time, this angiotensin 2 moves toward the adrenal cortex and it releases the aldosterone hormone from the cortex of adrenal gland, and this aldosterone act on the DCT and CT, which absorb the more sodium inside of the blood, and that's why osmotic pressure again increase inside of the kidney. And because of that, the water which is going to follow this sodium concentration, and more water is now trying to enter inside of the blood. And if you see the first thing from where we start, because of the decrease in a blood volume, and now here what is happening, the more blood is more water is entering into the blood. Okay, so that means the volume of blood is increasing, so we are going to achieve the things what is going to decrease before the start of the RAS system, and the more blood volume will again come to the normal, and it will give a feedback inhibition to the JJ apparatus cell or the JJ apparatus, and it will result in a less production of renin, automatically keys the production of every milestone in this system. Okay, so this is how the RAS system works. Now we have a second condition, like if you take a more water and a less exertion, it will uh, result into the more blood volume. Okay, the condition is very opposite to the first two condition. So due to the more blood volume, the blood pressure also increased. Due to the more blood volume, the blood pressure is also going to increase, and because of high blood pressure and the more blood volume, what is happening now? Let's see, guys. For example, this is your right side of a heart. Okay, so this is the right side of heart and this is a left side of heart. Okay, here we know the wall are here. Okay, so in the wall of the your atrium, the blood is coming from the lower part here. So this is your inferior vena cava. Okay, so it's a vena cava coming from the lower part of a body. Here is a second vena cava, superior vena cava, which is coming from the upper part of a body, like this. And if you see the more blood volume, because of more blood volume, the volume which is entering into the right atrium is a more volume is now entering into the right atrium, so it results into the more blood pressure inside the atrium. Okay, so if you increase the pressure inside of the atrium, it will release atrio sorry yes atrial natriuretic factor, ANF. Okay, and most of the time it is called as atrial natriuretic peptide, ANP. Okay, so the ANF and ANP are the same. These are the hormones, so you can say there are the endocrine cell inside of your heart also. Okay, so the heart is also a gland which secretes a single hormone. Okay, it secretes a single hormone, that is ANP or ANF, sometimes called ANF, atrial natriuretic peptide. So it is coming from the atria, all of atria. So we call it atrial natriuretic peptide. It is a peptide hormone made up of protein, made up of amino acid. So we call it a peptide or the factor. Okay. So it is a potent vasodilator. Okay. What is meant by vasodilation? So for example, this is your blood pipe. When it get a contact with the vasodilators, so it will looks like this. Okay, so the diameter is increased in the contact of vasodilator. Okay, so what happened, there is a more blood pressure, and now the blood pipes are more, so they hold more blood inside of the blood pipe. Okay, so the our blood pipe which takes more blood is a vein. Okay, our vein contains 70% of the blood of our body. Okay, vein मध्ये blood जास्त store होतं, जास्त blood vein मध्ये store होतं, because there is a less speed of blood in a vein. Okay, so speed is less, so it moves like slowly, and the more blood can store inside of the vein. So now your vein is getting more dilation. Because of that, the more blood is stored inside of your vein, and the blood pressure drops. Okay, so the more blood pressure, more blood into the vein, and because of the less blood is coming into the this part, or the blood is moving very slowly, so the blood pressure automatically drops due to the vasodilation. Okay, so if you see the vasoconstriction, it will increase the blood pressure. If it's a vasoconstriction, it will increase the blood pressure. Now in the vasodilation, the blood pressure is going to decrease, and because of the ANP, it has a second effect on the JJ apparatus. It will again reduce the renin concentration. So because of low renin, there is not conversion of angiotensinogen to the angiotensin 1 and angiotensin 1 to the angiotensin 2, and because of low angiotensin 2, low aldosterone is secreted, or it ceases, or it stops the secretion of aldosterone from the adrenal cortex. Okay, and then effect of a kidney is like there is a less absorption of sodium inside of the blood. Okay, so the result of this is inhibition of sodium chloride absorption, reabsorption inside of the blood, and that's why the water is not going to absorb more in the blood, but it's a complete opposite, the secretion of more water inside of the urine. So from where we are started, we are started because there is a more water inside of the blood, and now the water is moving inside of the urine. So the more water is moving inside of the urine, automatically the water balance is come to the normal. Okay, and when water balance comes to the normal, what happen guys, in the heart? Okay, in the heart, the water which is moving inside is now normal, and due to the normal water, or the normal blood which is entering into the atria of a heart will again result into the low pressure, and because of the release of pressure from atria, it will result into the inhibition of ANP, and ANP is inhibited, and when ANP is inhibited, there is a release of this vasodilation, and the blood volume or the blood capillaries again maintain its original shape or original diameter, and there is again maintenance of a blood pressure. And the second thing, renin is also not going to the inhibited further by ANP, because ANP is absent. So the feedback inhibition is also there, and they are maintained by the its own system. Okay, so the main player is a hypothalamus, which can sense the volume of blood and the number of sodium and the potassium or other ions inside of the blood. Okay, so this is a beauty of the maintenance of blood pressure and the urine concentration inside of the body. Okay, so the one more thing, guys, when ADH is there and a RAS system was there, so these are to troubleshoot the low blood volume. Okay, due to the low blood volume, they started and they end into the absorption of water from urine into the blood. Okay, and because of that, urine is concentrated. So concentrated urine is there. So this urine shows more yellow color, dark yellow color. Okay, then smell is also more. Okay, odor of urine is also more here. And if you see the ANF work like it will start when there is a more blood pressure because of the more blood volume. So the blood volume is more here, so we have to release the pressure by releasing volume from the blood. Okay, so when in the kidney ANF enters, or the ANF start its work from the kidney, more water is released. More water is released. So let's see, water released in urine, and it will result in a low concentration of water in blood, so it maintain. So here more water in a urine, that means urine is diluted, so diluted urine is here. And in diluted urine, more water. Okay, a less yellow color and less smell, or very little smell is there. Okay, so this is how you can get a question, or you will have the question in the examination, like the reason behind the concentrated urine and reason behind the diluted urine. Okay, so don't get confused with this concentrated and the diluted urine. Let's think what is meant by concentrated. So less water. Why water is less? Because the water in a blood is less, so the blood absorb more water. And why blood absorb more water? Because of ADH and RAS. Okay, if they are talking about the diluted urine, that means indirectly they are talking about the ANF. Okay, so guys, if you are late, it is difficult to say you that what is a RAS. A RAS is a renin, angiotensin, aldosterone, not a H, it's a yes, renin, angiotensin, aldosterone system. Okay, so it's a RAS. So who are late, please see this video from the first slide. And those who don't know about the most part which came inside of these slides, so please see my last video. And is there any difficulty in the last video, please see my first video of excretion and osmoregulation. So those who do not understand the most of the part, please see the series one by one. Each and every video is about 1 to half hour. Okay, so 1 to 1.5 hour. Okay, so it is a beautiful series. If you see one by one in a single a day, it will give you the lot of knowledge about the excretion and osmoregulation. Okay, so guys, thank you very much for supporting me. If you do not subscribe our channel, please subscribe my YouTube channel. This is a Crack Maharashtra CET. Okay, and join us with India's largest platform, the Unacademy. It will definitely give you the more marks in examination. We will definitely explore more here if you support us. Okay, so thank you very much, and see you tomorrow at morning 11 p.m. 11 a.m. With the new lectures and new ideas to understand the concept in biology. Okay, so thank you very much, guys.